It's lesson 12 of enterprise computing. We're going to start adding unit tests to our MVC music store. Just before we do, just want to chat briefly about unit testing. So my first question is the big why. What are some of the reasons to think about unit testing if you think about what you did with Java previously?
I have to manually test every single method.
Yep. Bigger. Anything else? What are some of the other benefits of doing unit testing?
We can use application with so many classes. We can make sure that if we build one class, we test this first before stepping ahead.
Okay.
To the next one.
Yep. So let's Yep. Any other reasons to unit test? What else does it offer us? Any other benefits to doing it as opposed to other kinds of testing?
I don't know any other types of testing that there is.
Okay, we'll talk about those. Okay. That's the next thing we're going to look at. I'm just going to read you guys. I'll read you this little quote. I'll paraphrase it a bit. It's by a developer by the name of Scott Guthrie, who's been one of the leading .NET developers since .NET came out in 2002. There's a very good chance if you look up any .NET tutorial, there's probably about a 1 in 2 chance Scott Guthrie is the author of it. So you'll find tons of resources by him. So he kind of paints this scenario. He says, you're driving to work one morning and you suddenly get an inspiration about an application you're working on, and you realize there's a change you can implement simply that will make the application dramatically better. Either it's going to optimize the code, it's going to improve performance, it adds a new feature, or maybe it fixes a bug. And by the time you get to your desk, your enthusiasm is somewhat diminished because you now have one big question and one big concern. What's that concern before you go ahead and implement that change into an existing code base? Right. What are the implications of me making this change? Sounds good in theory, but what exactly, as Sean said, what might it wreck? Okay. So it may be simple. It might be simple for me to make and implement, but what if it takes hours to manually test out all of the possible scenarios here? Or what if I forget to cover one of those scenarios and then we wind up putting broken code into production? Okay, is my improvement worth all the potential aggravation? So this is primarily what unit testing is designed to save us from. That we can make a change and know we can rerun the automated tests on our existing code base, and that will easily and quickly tell us if our change broke something. So that's kind of the real hidden beauty. In sort of in his words, he calls it's a safety net, right? So for being able to maintain applications over a long lifespan, unit testing is critical. So it allows us to test the implications of our changes on existing code. And if we do test-driven development, right, it allows us to think through all the possible execution paths of a method before we write it. Now, we're not doing test-driven development, but that goes hand in hand with unit testing often, right? We basically can think about writing the tests first. What are the possibilities?
Do you ever do that, Jordan? Any of the classes often TBZ?
I don't know is the simple answer. So you've kind of described what unit testing is. It's testing an individual method, a unit. We're not testing a class, we're testing all of the methods in a unit. if you think about a large scale application, let's think of a web application. We're using an MVC framework, so all of our methods are in our .NET controllers. So we'll want to unit test all those methods. Even though they're scaffolded, maybe we didn't even write the code, Visual Studio wrote the code, we still want to test all the execution paths. What other kinds of tests? If the music store was a real site, we had a client launching an online music store, and we were going to build this. Aside from unit testing, what other kinds of testing do you think we might do before we launch it? I can think of, this morning we talked about maybe 4 or 5 other kinds of tests. What other kinds of?
The user experience.
Okay, yep. So we'll have. Yep. So user experience, or what's more commonly known, user acceptance testing. So we put it in the hands of either our customer or like a group of beta users who might be using it, and we let them try it and we get feedback from them, either to report bugs or even just to tell us about design flaws or things that aren't clear to them, ways we can make that experience easier. And we often want to sit in and observe that, or provide, a focus group, a survey, some easy feedback mechanism for them to report back to us. So that is one thing we'd want. What else would we want to do from kind of a quality perspective? Test the individual methods, get feedback from end users. There's probably, I can think of 3 other things at least we would want to test, particularly if it's web.
Testing connections.
Right. So if we test on different devices, different connection speeds, is the application usable? Or does it work flawlessly, but it's so slow that nobody's ever actually going to sit through the use of it? Anything else you can think of? What's one of the big dangers of launching a public web application as opposed to, say, a desktop application that we were to install like within a company? Okay, yep. Sorry? Yep, so that would be part of it. Yep, so security would be wrapped up in that. What about the difference between if we kind of knew how big our user base was, right? Like if we were going to install an application for a company, we have a pretty good idea how many users they have in that company. If it's a public web application, yeah, so we've got load testing, right? So what happens if we go to our checkout page and we simulate 20,000 concurrent requests of our checkout page? Does it still run? Right? So load testing is a little less important when we have a controlled user base, but it's particularly important for web and mobile because we're often launching these things as public applications. And the idea is we want thousands or 100,000s or millions of users ideally. So is it going to be able to, is it robust enough to, and is our server infrastructure robust enough to handle that?
How do we test that?
There's software that will simulate, so we can put in a URL and it'll make 50,000 requests to our homepage all at once and log the results and log the, so it's sort of related to performance, but performance testing can also be for an individual user. Load testing is simulating many concurrent users and connections, right? Does our database bottleneck, for example? And then the other piece is integration testing. So that's where we take our application code and we look at what are all the other components that web application talks to. So even our music store right now is integrated with 2 other applications. You think just of the web application code itself. What are the 2 things our music store is integrated with? Oh, actually, I guess 4, right, sorry, 4. So there's Google, Microsoft, those are 2. Facebook is 3. What happens on our checkout page? What are we integrating with?
Oh, that's Stripe.
Yeah, we're integrating with the Stripe gateway. So we need to test that. The last other thing, which is kind of underrated and is going to cause us to have to make a lot of changes in our application today, is the database, right? When we do unit testing, we want to divorce the methods from the database. We want to test the methods themselves with no connection to the database, which is kind of tricky because right now all our methods are tightly coupled with our SQL server and the entity framework. So we need to, in order to unit test, we kind of have two tasks. We have to decouple the methods from the database. So we need to fake out or mock the database. But at the same time, we don't want to break all our existing functionality of our website that does still use the database. So we're going to kind of re-engineer one of the controllers. We won't do it in all of them, but we'll walk through the process of how do we kind of refactor that controller so that it can both do unit testing with mock data, but can also still integrate with the database.
Just because we don't want to enter, say when we are testing, we are just typing some non-relevant data, and we don't want that data to insert into the database. So that's why we are faking the database.
Well, that's part of the reason. That's a good reason for it. But the reason truly is a unit test should be testing the one method and one method only. We want to test whether our details method works, right? Does it, if we pass in an ID, do we get the right type of object back? So it's not about, is our database connection working? Is our database structure sound? That's an integration test where we're testing, does the web application pull data from the database correctly? That's no longer a unit test, it's an integration test. So it's still important, but we're going to we're breaking this up into a smaller measure. But that will mean re-engineering our controllers because right now they're tightly bound with the database.
Sorry, we have notification for unit testing quiz.
Yeah, that's not happening.
Ignore this.
You can ignore it. I decided we weren't going to do it.
I had this notification at 10.
So what we'll do, we've only done a couple labs. I'm just going to increase the weighting of the individual lab because we said 10% for in-class labs or quizzes. We had 2 labs. They'll be worth 5% rather than 2.5. We won't worry about the quizzes. I don't want to give you guys more labs. You have enough graded work to get done. I don't want to add to it at this point in the semester. Right. So I'll just kind of leave this up. We may come back and refer to it a bit through the class. So in order to do this, so we're going to want, in order to break the integration, we need some kind of mocking tool that you're going to look at. So if you want to just open up your solution from last week. And I have a few things here on Blackboard I just wanted to kind of touch on before we start. So we're not unit testing the API. No, we're unit testing the actual website. So load the MVC web application. Because one of the things we do as we start ripping it apart for unit testing, we want to make sure all the functionality in the website still works. So our unit test basically piece of code that tests the behavior of one function or class. And in many large scale enterprises, they'll often have either 2 separate teams, one to do development and one to do quality assurance. They may even hire, if they outsource all the work, they may hire company A to do the development and company B to do all the testing. Because the most effective testers are not the developers. It's people who had no stake and no understanding of the development, right? That's how you get really good testing done. So today's lesson, I'm going to point you to a few resources that I've used. And what I've done is kind of borrowed some of the ideas and concepts from this tutorial series on Visual Studio Magazine, which is really good. They screenshot everything. They show you all the code. It's a 4-part series. And Rick, if you're interested in TDD, this is unit testing with .NET MVC in a TDD context. So I've borrowed some of the things here. The other things I've borrowed is from this. It's a 50-minute tutorial by Craig Bernston, who's a very kind of well-known seasoned .NET developer, where he walks through, again, .NET MVC unit testing. So I've borrowed some things from him. He also uses a mock framework, for a mock data framework. I didn't use we're not going to use the same one he did. I used one that's more popular. He also doesn't unit test all the methods in a controller. We're going to, by the end of next week, we're going to unit test all the methods in one controller. We'll try to get 100% code coverage, or as close to 100% code coverage as we can in one of our controllers. We're not going to do it for all of them. Okay, but it's going to be the same process basically. Do it in one, be pretty much similar to write the unit tests in your other controller. So I'll leave these here. These are here for you as resources. So I don't claim to have written all this myself. You know, I kind of got my inspiration from those lessons, and I've pulled them together and tried to integrate them into our music store. So what we do need here, just kind of close everything up. Oops, I opened my API, which I didn't mean to. I want to open the actual web application itself. So I'm going to close most of these windows. Actually, I'll just close everything up. So we actually have here, if I just contract, when we created this project back in week 1 or week 2, we enabled the unit testing option. So that's why our solution says 2 projects. The main project, which is set as the startup project, it shows in bold. That's our web application. But we also have this little test project here. So if we look in here, there's no web.config. There's actually an app.config. We're not going to use this file, but it's an XML, not particular to a web application. We have a place for a connection string if we need one. We don't want one because we're using this for unit testing, not integration testing. So we're actually not going to touch this file. And in here, we actually have 1 controller. We have 3 unit tests already here, which we'll look at in a bit. So what we want to do, it's just going to figure out. So in this morning's class, we unit tested the orders controller. I think this afternoon we'll maybe unit test a different controller. It's going to be the same process, but I think we scaffolded out this artists controller. So we'll maybe unit test the methods in here. So if you're watching this video and you didn't come to the morning class, but you're in the morning class, our morning lesson is going to be a little different. Okay, so you're going to have to adapt what we're doing for artists to orders. So here's our controller. So here's the challenge that we have. Well, we're going to need some kind of mock framework, because right now our controller, as soon as you instantiate an instance of our controller, what does it do? Connects to the database using our entity framework DB context. So borrowing from Craig's video here, I'm going to show you the only 5 slides of PowerPoint you're going to see all semester in my class. I know no one likes PowerPoint, so I don't beat you over the head with it, but I do want to give you a few visuals. Okay? So I've referenced Craig's video. Again, these aren't my slides. I've taken some screenshots and cropped them because I think his visuals are pretty good to give us a picture of where what we're going to do. So this is what our controllers look like right now. Right? As soon as you instantiate a controller, it calls our DB context, our music store model, which uses entity framework and connects to our SQL server based on our default connection that's in our web.config. You can't create any, so even when we scaffold a controller, every time it works like this. The problem is we still want this to run when we're running our app live, but we don't want this for unit testing because we want to decouple our controllers from the database. So when we're unit testing, we want this structure instead. Sorry. We want our controller, we want to inject this layer here called a repository layer. So when we're running our application live, we're going to, rather than our controller automatically call the database, the controller is going to call a repository, and our repository will do the database connection. So we're kind of decoupling this direct connection between the controller and the database context. So this will be the path still when someone's running our website. We're just adding in a layer here. So we can kind of break this automatic coupling.
Just for testing.
Well, this is so that we can include testing. This will be the path when we're running live, not testing. We're adding a layer in, this repository layer. For testing, it's going to look like this. We're going to have a separate repository that just deals with mock data. So we'll have like method stubs. We'll have like a save method, but it doesn't do anything. It's just like a method signature. Nothing actually. So we're going to have these two paths. So then the question is, how do we make our controller dynamic so that when the application's running live, it takes this path, and when we're doing unit testing, it takes this path. So we need a way of telling our controller to do one or the other. But then we want all of the rest of the code in the controller to work either way. We don't want to have to write a whole bunch. We want to write an if statement with different logic in every method, right? We still want the methods to run, but run the same way whether they're live or mocking. So here's the magic. So in our controller, we're going to use a technique called, which I'll add here. I put it on the board this morning, but it'll show up in our video. We're going to use this method called dependency injection. Anybody heard that term before or have an idea what it means? Basically, kind of the simple version is, this is my own definition. We could find a more technical definition online, but in simple everyday language is we provide a needed dependency or not at runtime. This dependency determines what an object should do. Yes, if we provide to an object. So when we create an object, we can give it something, kind of like a parameter. But rather than just being a regular parameter, we're giving it an object. And that object will dictate how, that incoming dependency dictates how that object should behave. Okay. For example, let's say I gave you you had a big bowl of noodle soup. Okay, so you have a big bowl, you have broth with a bunch of noodles in it. Okay. If I gave you a spoon, what would you do? What would you eat first if you got a spoon? Yeah, you'd probably eat the broth, right? If you got a fork or chopsticks, what are you going to eat first? Yeah, you're going to eat the noodles, or you're going to eat the noodles first, right? So what is provided to you determines how you behave. So we can do this programmatically. So we need to use dependency injection so that our controller can take either of these paths. If we hand it some kind of mock data, we want it to take this path. Just use our mock methods and don't connect to the database. If we hand our controller something else, that means we want it to use the database. The other way we can the other way we could do it is, the way we'll actually implement this is, if we hand our controller nothing, that's the default. We don't pass anything to the controller. Our default path is use the database. But if we say, hey, controller, here's a bunch of mock data, we want it to go this way instead, not that way. And we'll see dependency injection. It's not a .NET concept. It's used widely in many languages. Actually, next semester, when you guys, when you do Angular uses this model. So Angular is to inject dynamic JavaScript components into HTML pages. So we use dependency injection, so at runtime, our HTML can take different JavaScript components and render them. And it's all called as the application runs. So in order to do this, we'll have to break this and kind of rebuild some of it so that it can handle both execution paths. So in order to get this to run, writing the individual unit tests are actually pretty simple. The real kind of work and the part that a few people were sort of scratching their heads with this morning is the setup of all of that is fairly involved. We've got to set up mock data, and then we've got to rejig our controller to handle dependency injection. And then we also need to build these new layers we talked about. We need a database repository, and we need a mock repository. And then the controller has to decide which one of these repositories should it use. So that's kind of the overview. I'll come back and probably refer to this diagram a fair bit as we go through today. Now, you guys, I think did you use JUnit when you did unit testing in Java? Yeah. Okay. There are a bunch of different .NET unit testing frameworks. A really popular third-party framework is called NUnit, and I believe in this video, the developer uses NUnit. We're actually going to use kind of an older testing framework that's baked right into Visual Studio called MS Test. Right? We'll use mock for the data, and we'll use MS Test to actually run the unit tests and report on code coverage and things like that. So we'll come to mock in a minute. I just wanted to kind of give you an overview of how this all fits together and what we're going to do. So we actually have in our test project, we actually have a home controller test class. So the Visual Studio template sets this up so we can look at it. If you expand your tests. So we've got references to the unit testing library, Microsoft's unit testing library. It references the controllers of our web project. And basically the name of our class, it matches one of the web controllers. This is the word test on the end, right? But it has this decorator, the test class. And now we've got 3 test methods, right? Our home controller in our web application has 3 methods, index, about, and contact. So this sets up 3 methods, and they're all indicated with this test method annotation above. So you can see they've each got these little blue icons. That tells us this test has never been executed. So we can execute either an individual unit test, or we can a selection of unit tests, all the unit tests in a controller, all the unit tests. We got lots of options for how we execute this. So it follows unit testing in .NET, same structure as unit testing in Java. Arrange, so set up whatever we want to test. Act, call the method we want a unit test. And assert, evaluate the result. Did we get the result we're expecting? So our goal is to get all our unit tests to pass and to get as much code coverage as we can. So if we want to run these, and actually, sorry, I'll just open up the home controller for a minute. And the quick way to get here, if you didn't know you can do this in Visual Studio, if I just right-click on that and choose Go to Definition, it'll open up that file, right? So it jumps me to my home controller. So we've never seen this before, but you notice it actually tells you for every method, this is how many tests there are in the solution, and this is how many of them have passed successfully. So for each one of these, it says 0 of 1, because none of these unit tests have ever been run. So to run them all, we can either run them individually. So I could click here and run all, or I can just click the test method and I can run a selected test. I'll just run all tests on my test method. And it's going to pop open a little window over on the left. It's going to compile the application. So before it runs the tests, it wants to make sure it's getting the most recent version of the code. And 2 of our 3 unit tests pass. So index and context and contact pass, about fails. So we get a little green check mark here beside the index test and a check mark beside contact. About fails. So if we want to see why, there's 2 places we can get that information. You can click the X here and you get it in the pop-up.
I don't see those X references.
It may be an option in Visual Studio you have to turn on. I'm not sure. Are you using the professional or the community edition? Visual Studio. Go to help and about. I'm using the enterprise version. Those may not show up if you've got the community edition. The test will still run though. Yeah, that's probably why. You can also, I can also click the name of the test here on the left and it shows me in this panel. So here's why the test failed. It expected your application description page. That was what was expected, but what was returned was this is the about page. Because way back in week 1, we changed the message that got returned in the controller. So our unit test fails as it should. So how would we correct this to get our unit test to pass? That's right. We should change the test, what we expect in the test, to match what we're sending in the controller. And there's no period, I don't believe. I'll open up, go back to my home controller and just open it up. Yeah, there's no period in our sentence here. So if we add that same message, we'll have to rebuild. And now I can just run the failed test and it should pass, which it does. So now our test is matching what our method returns. Now we can check, there is a code coverage tool. There's one thing that annoys me to no end that I can't believe they haven't fixed. The code coverage tool works, but it doesn't, there's no refresh. So like getting into the code coverage tool is kind of a pain. And every time you run the tests again or you make new tests, you have to go through the whole process of analyzing the code coverage every time. You should just be able to click refresh and it should rerun the code coverage, but it doesn't work. So we can check the code coverage here through the test menu, analyze code coverage, and I'll pick all tests. So it builds everything. And then we can go in and kind of drill down to my home controller. And here's our code coverage. So about and contact are not entirely covered. Index is entirely covered. So if we want to see why, here's why. So one of the other things it shows me, I neglected to do this in the morning class. So if you're watching the video from the morning, you haven't seen this yet. The yellow tells us that that's, well, sorry, this part where it's blue saying so the blue is tested. We never checked the view bag. So that's why we're not at 100% in our about. We checked the message in the page. Sorry, it's the other way around. So yeah, the blue indicates that part's tested successfully. The yellow hasn't been tested. So like on contact, our test just checks that we get back a view. So the return view is tested, but there's no unit test for what's in the view bag right now. So if we added a separate unit test to check the view bag on the contact page, that code coverage would probably go to 100%. We could try that quickly. How? Yeah. Through test, analyze code coverage, and then you have to start drilling down. So Jaspreet, I expanded my music store project, controllers, home controller, and then I can see the coverage. So what annoys me is if we write another test now, there should be a refresh button here. that will just run it again and give me the result. You have to go through the whole process again of test, analyze, run it, and then I have to expand that whole tree again.
Really don't plug in command shortcut for this?
One that I'm smart enough to know, no, maybe there is. But it's just the drilling down, because in order to see it, I'm really only interested in this one controller right now. So you may be able to rerun it, but that won't automatically take me back here. And there's no like refresh button on the toolbar. I can import, export. Oh yeah, so this is the button. If you don't see this coloring, it may be off by default. Notice when I click it, the code coloring turns off, the coverage coloring. When I enable that, that's when I get the blue, yellow, red. So by enabling that little button that says show code coverage coloring.
Hover over tests there. I don't see that coverage.
Test, analyze code
I
coverage.
don't see that.
That
I have only 4 or 5 options.
I think it's because you're on the community edition. I suspect there may be a way to enable it in the community edition, but we'll have to search for it. So we're not really too worried about what's in the home controller. And in your project, you have a home controller test file because it will have been there automatically. You can delete it. It has the passing unit test for about index and contact, not required for your project. I'm not going to evaluate the scaffold, the code that Visual Studio wrote. So what we want to do, we want to unit test our artist controller. So we'll create an artist controller test class in our test project. So scroll down in your Solution Explorer. We'll right-click controllers. And we're going to add a new item. And from this window, if you click Test, which is the last section under Visual C#, we want this one that says Unit Test, an empty unit test class declaration. We could create it as a regular class. The reason I'm going to pick this is because it will already have the reference to the unit testing library. So we don't need to add that reference. But if you create it just as a generic class, that's fine. So I'm going to call this, follow the naming convention. So this will be artists controller test. It references the Visual Studio Test Tools unit testing library. Now there's a bunch of stuff here we don't need. In fact, and notice, so our class has the test class annotation, which is good. I'm actually going to delete everything inside of it. There's like a original test method one. There's a constructor. We don't actually need any of that stuff. We're going to manually write all the unit tests here. So we'll write one unit test. Let's write a unit test that tries to load and execute the index method in our artist controller. It's probably not going to work, but we want to try it and see what happens because it's going to be somewhat informative in terms of how we decouple the controller from our database. So in here, let's create our first test method. We'll put that test method annotation. We'll call it public void index view loads. We want to try and call the index method of our artist controller and just see that it loads a view for starters. So we'll go through this. I always get the order mixed up. Arrange, right, act, and assert. So our arrange is we need to instantiate an instance of our artist controller. get rid of that. Doesn't know what artist controller is because we're in a separate project. So we get a reference error. Simple fix, right? Use your Visual Studio light bulb. Reference the controller's namespace in the web application project. And in fact, if we look at our home controller test, right, there's a reference to the same namespace. So we can access a controller there. So for act, we'll create a variable called actual equals controller dot index. Call the index method, which returns the system.web.mvc action result object. Right, that's the return type of all of our scaffolded methods. So here's our index method. It returns an action result, as does details and everything else. So just to do a simple assert here, so I'm sure you would have found similar kinds of assertions in JUnit, right? You can test that things are equal, that things are not equal, that they're null, that they're not null. Those would be the common ones. Let's just assert that what returns is not null. So we'll use is not null actual. We get something back when we call index. We don't really care what it is. Just something's coming back of type action result or a child of action result. So let's build this. And now it shows up here in our list of not run tests. I'm not going to rerun the test from the home controller. I just want to run this test. So I can just right click and run it from here. And it fails. No connection string found in application configuration file. So our connection string lives in the web application project, but when we're calling index from our test class, it doesn't have a database connection. Now, we don't actually want it to connect to the database, right? We're trying to execute, we want to go along this pathway. So we don't want to instantiate our database. We're getting this error because as soon as we call this class, the first thing it does is use the entity framework and try and call our database, except in this case, there's no connection string. So this line of code is going to need to get changed. We do not automatically want to connect to the database every time we create an instance of this class. Only sometimes. So this test is going to fail until we can kind of re-engineer this. It's not that we're deleting it entirely, it's just that this basically needs to be conditional in a way. So this is where our mocking framework kind of comes in. So we're going to use actually, I'll keep this video here. Open it in a new tab. So there's a couple ways we can install mock. You can use the NuGet package manager console and just type the command install-package mock. You don't need the version. You don't specify it will install the latest. Or you can use the visual NuGet package manager where you just browse, do a search for the word mock and install it. The key here is, though, we don't want to install mock in the web project. We want to install mock in the test project. And I'll show you both ways of how to do it. If you want to use the visual, you go to Manage NuGet Packages. Make sure you're in the Browse tab. And search for mock. When you click on it, we want to install it. You need to check off that it goes in the test project and then install. That's the GUI way of doing it. Search for mock under browse, select, but make sure you check off the test. We don't need to install it in the web project, just the test project. If you want to use the command line tool, which is similar to how you're going to install packages next semester in advanced web programming, you can go to Package Manager Console. And same down here, it says default project is the music store. So you want to change that. We want to install it in the test project, and you just run install-package MOQ. But it takes a copy of the source code from the NuGet central repository. And it says, hey, your app.config is open. You've now added a reference to this package. Do you want to save the changes to app.config? I'll say yes. I don't really need app.config, but now you can see I'm not sure why it didn't write my dependency. Doesn't matter. We're not concerned with that. So either way, use the GUI or use the package manager console. So next semester when you're doing Node, all your packages are installed through the command prompt using Node package manager. So you run the command npm space install space and the name of some package you want. So you'll do that, be basically doing that every week, installing different packages, because Node is super lightweight. And typically you have to install lots of stuff on top of it as you need it. Okay, so mock is installed. So now we should have a reference to it in our unit test list of dependencies, which we do. So our next step now, we need to deal with this. So we've got to, remember I said, we're going to, so here's where we are now. Controller talks to data, controller talks to connection class, DB context talks to the database. We need to insert this layer in between, kind of like a buffer. So the database context does not call directly from the controller. So this is our path when we're using live data. And then this is our path when we're using mock data. So we're going to create these two repositories. So in our Solution Explorer, I'm going to create these inside of my model. Now we could create them in a separate place. I'm just going to put them inside of models. So first, let's do the mock interface. So we're going to add a new item. And I'm just going to search. This is going to be an interface. So it's like a template, but it doesn't actually have real actions. It's just dummy. So what I'm going to call this one is I mock artists repository. Kind of a long, clunky name, but it describes what it's doing exactly. So we are only using this when we're unit testing. This file does not get called when the application is running live. Shaughnessy is squinting. I mock artists repository. Or you can call it artist singular, doesn't matter. We do. So it defines it as an interface, which we need to make public. Because we need to be able to view this from our controller. We need to be able to view it from our unit testing class. So in order for this interface to kind of handle unit testing for create, read, update, and delete, we only need 3 lines of code here. It's pretty simple. The first thing that we need in this interface is a list of artists The second thing we need is a mock save method. The method doesn't have to oops, sorry, I've defined it as a list. Sorry. Rather than a list, we're going to use this iQueryable. So we can execute a query against it. So we've got a mock save method and a mock delete method. The methods don't have to do anything. It's that our controllers can at least call them with mock data. So we've created our mock. We'll have to use dependency injection soon to tell our controller when to use the mock. Because again, it might use this path or it might take that path. So there's our mock repository. So we've built this layer. Now, we now need to build this layer. We need to build another repository, but this one actually uses the database when our application's running in production. So we're going to build one other class. It's not going to be an interface. This will be an actual class, and it needs to inherit from this class. And I'll explain why. You'll see why in a bit. So let's make one more model. So let's add. This time we're going to add it as a class. And this one, instead of calling it iMock, we'll call it, maybe we'll call it EF Artist Repository. So this one uses the entity framework to talk to the database. I called it EF Artist Repository. So instead of iMock, it's EF for entity framework. So this version is going to inherit. I'm going to add here in the definition a colon. It's going to inherit the interface. Now it doesn't like this. It says, okay, well, if you're inheriting from the interface, you have to implement the interface. Where's the artist property? Where's the save and delete? Well, Visual Studio, please implement the interface for us. Now notice they all say throw not implemented exception, but it's a start. We're obviously going to have to replace the throw not implemented with actual code that talks to the database. So now we don't actually have to write separate insert and update methods. Save can handle both of those. So what we're going to do is change this. So when a list of artists is requested, now we'll run a command on the database. So our get method will return now. Doesn't know what the DB is. So we want to make reference to our database context here now. We're going to take it out of the controller, and it's the repository that's going to call the database. I meant to do that, right? So we need the reference to our database. So in here, dbcon moved here from artists controller. The database connection happens in this repository. It no longer happens in the controller. I know it's still in the controller right now, but we'll change that. We'll leave, delete, and save for now. We probably won't get to those today. For today, we want to be able to unit test our index and details methods. We can deal with the create, edit, and delete methods next week. So we can just leave those as not implemented for now.
You don't have a set method in your.
We don't need one. We never need to set the list. We just need to get the list from the database. I mean, it would be okay to write a set method, it just isn't necessary. And because this implements iQueryable, it means we can use this for details as well, right? We're just querying one item in that list. So we don't need a separate details method in our interface. So we'll save those. So we've now set up the two repositories that we need. This slide really should have two repositories because we have two separate ones, right? We have a mock repository and we have a separate entity framework repository. But I borrowed this from, like I said, this is a screenshot from the video that I've kind of cropped out. But we're actually creating two versions.
When I modified the first method, it again asked me to implement the interface.
Yeah, so what we'll, here's the way we're going to handle it. Let's go back to our controller. So I'm going to comment out this line. We don't want to hard code our connection here because when we're mocking, we don't want to instantiate an instance of our database connection. So I'll say DB connection moved to EF artists repository. I'm going to comment this out. I'm going to replace it. I'm not going to get rid of my DB because notice our scaffold code, it all uses this DB dot everywhere. So we still want our DB variable, but now it has two possible meanings. Originally, DB always meant our database connection. Now our DB will mean one of these two files. If we're testing, it means this file. If we're not testing, it means this one. And this one uses the database. So I'm going to redeclare DB. But I'm going to change the type to be our mock. I'll explain why in a minute. Remember, our database repository, it inherits. Right. So we've got all the properties and methods of the interface, regardless of if we're testing or working live. If I don't inherit, well, at the moment it'll work, but in a minute, because I inherit it and somebody asked a good question, do we have to inherit from there? And we'll see. I'll break it in a minute. So now we come to this point, to this part, kind of the most advanced technique, the dependency injection part. Where when we're creating the controller, we need to decide what are we giving to this controller? What does it need? And that dependency will determine whether the controller uses the mock repository with fake data or whether it uses our entity framework repository and our SQL server. So the way we're going to do this is we're going to write two constructors. Our controller right now, when you scaffold, it has no constructor. So what we'll do is we'll write two constructors, an empty one. So if nothing's passed in, the default path is use the database. Because most of the time when our controller is called, our app's probably in production and we want data. So if there's no parameters, we want to use this repository. Talk to the database, work with live data. But if we pass in some mock data, we want to use the mock repository instead and have no database connection. So we'll set up those constructors and then we'll maybe take a pause. So this will be our default constructor. It has no dependency. Incoming. We'll use the database. So in this case, if nothing is passed, use whoops. We'll instantiate it. If we don't pass any mock data to the controller, we're not unit testing, use the database. But rather than the database connection happening in this file, it happens in our repository. Here's our mock constructor that has a mock object passed as a dependency for unit testing. So in this case, the object that's going to get passed is of type so then we set this.db equal to the mock repo that comes in. So we'll pass in an interface with a bunch of mock artist data. So if we hand the controller mock artist data, just use the dummy interface. We're testing. If nothing gets passed in, we have no dummy data, so we run live, we connect to the database as usual. That's kind of the logic of how dependency injection works. So what this will allow us to do is will allow us to run all of these methods in the same way, no matter if we're unit testing or if the application's actually running live. Now, one quick way to check this. So now our index, notice our index calls DB. Well, our DB is no longer a direct database connection. This DB here, if nothing's passed in, it's now referring to this version. So it goes into the repository. I want to make sure, we'll take a break in a minute. I want to make sure I haven't broken anything. So the way to check is to start the site. I want to make sure I can still call artist/index and get a list of artists. What's the problem?
On my artist controller, I have tons of red.
Yes, here's why. So in our details method, find is under, I should probably turn off the color coding for a minute. It's kind of hard to see. Yeah, the red has to do with the unit, what's not unit tested. I'm going to turn that off for just a minute.
I get that the EF artist repository cannot be used like a method.
Yeah. Bear with me for a second. I may not be able to turn off the color coding yet. Yeah, sorry, I'll have to wait. So notice in most of the methods here, so in details, find, it says there is no find in your interface, so find isn't going to work. It says create, add and save changes aren't going to work, right? Because those methods don't exist. We only have save and delete. Same here, find, save, dispose. So what we'll do for now is we're going to comment out all of the methods in our controller just temporarily, except for index. And then we'll put them back in over the next class and a half. So from this last method, this override dispose, right up to and including details, let's just comment it out. So the only things active in here, so you should go right up, should be at line 37 is the start of details. I just comment all that stuff. So the only active methods here are index and my two constructors.
How do you comment all those, that whole block?
I have these little toolbars here. If you don't comment and uncomment, if you don't have it, Sean, if you go to View and Toolbars and turn on the Text Editor toolbar, you'll get those.
I still have error when I'm implementing the iMock artist repository.
What does it say?
Implement the interface. I have seen methods. I just modified the first one, the artist, and as soon as I do it, it says you are not implementing interface.
Okay. So your EF artist repository has to have an iQueryable artists,
Yes.
a void delete method,
Yeah. And an artist save method.
and an artist save method. I'll have to have a look. I'm not sure without seeing it. So all I want to check now is that I can load it in my browser and go to /artists and still get the list of artists. Because it's possible that we've broken that method. I want to make sure it still runs. So we'll load the site and here's the real test. If I go to /artists, so index still work. Details will fail because I've commented out the method, right? So details isn't going to work right now. But at least our decoupling of the database context from directly being called in our controller, it still allows our index method to run. It's just passed through this kind of intermediary, this repository and the repository. So when we pass nothing into the controller, right, our default path is still the database path. We're not passing any dependency in here, so it calls the repository, which uses database context, and our data still comes back. So we haven't broken this yet, which is good. So our index still runs. What we will do, we're going to take a break. Our next steps when we come back is we now need to set up, to use that mock package, set up some mock data and try the other constructor. What happens when we pass mock data in, and can we write unit tests with our mock data so that our application is not connected to SQL Server when we're unit testing? We're going to substitute in and work with the mock data instead. So we're going to write unit tests for index that it actually returns a list of artists. And then we'll look at the possible unit tests we need in the execution paths for details. And then I think we'll stop there and we'll deal with create, edit, and delete next week.